Welcome to the Smart Driving Cars podcast. We appreciate your being here and hope you enjoy our discussion with another interesting guest. This edition is sponsored by the Smart ETF's Smart Transportation and Technology ETF, symbol MOTO. For more information, head to motoetf.com. I'm Fred Fishkin, along with the Faculty Chair of Autonomous Vehicle Engineering at Princeton University, Alain Kornhauser. Hi again, Alain.
Hey, good morning, Fred.
And joining us this week is the founder and CEO of Perceptive, Alberto Stochino. Alberto, welcome aboard. Thanks for taking the time.
Hi, Fred. Alain, thanks for inviting me. Excited to be here.
Very nice to have you.
Well, the tagline on your website at perceptivesensing.ai says, reinventing sensing for autonomy, a fundamentally new sensing architecture for truly driverless vehicles. Take us through a little bit of the background and what it is that you're doing.
So we've been in this space for many years. And so we realized that while we made tremendous progress and it keeps actually happening, the challenge was really big. And especially one of the biggest challenges of autonomous vehicle was trying to make sense of the world out there in an actionable matter, in sort of like a human matter. And the way we've been approaching this problem so far has been quite limited. So if you want, we still had this divided, if you want, serialized approach between sensing and perception. And we believe that that has just led to this brute force approach that has just made autonomous vehicles more complicated, more expensive, difficult to scale, and left the problem unsolved. So we decided that it was time to actually, if you want, this first generation of autonomy, this first attempt to go back to the fundamentals and approach sensing in a different way. So we started to develop a sensing platform, if you want, for artificial perception. If you want, we want to enable AI, robots, and autonomous vehicles to sense and perceive the world in a meaningful way. So we believe that actually sensing and perception are just one, and they should actually go hand in hand since just the earliest stage of the interface with the physical world. So we have started by building a comprehensive sensing system for autonomous vehicles that could actually really bring us to the highest levels of autonomy. If you want, we always recognize that there was a very big difference between, if you want, the lowest levels of autonomy, level 1, 2, and 3, versus 4 and 5. We recognize those to be two very completely different problems. And so we decided to focus on 4 and 5 that actually was raising a much bigger challenge to technology and to developers than just level 2. So we decided that a very different approach was needed for that. So ergo, that's where Perceptive was started. And we are happy to tell you more about actually how we started to actually look into sensing in a different way.
Yeah, well, describe that for us a little bit, a little more detail. What sets you apart? What do you mean by creating this new platform?
Yeah, absolutely. So if you think of sensing as just a problem of mapping the world, like maybe extracting these very high resolution maps and scanning coordinates of the world around us, and then having intelligence to try to extract information and meaning about that. If you look at this in this sort of like a two-step approach, it's almost intractable. It's too much information. And there is no such a thing as sensing and then perceiving. Perceiving and sensing always happen at the same time. That's how actually our limited finite brains can actually make sense of meaning and semantic content out there. So you always have and always see very sparse, noisy, patchy information of the objects out there. And it's this continuous, very fast interplay with your intelligence and your sensors and your sensing that eventually fills those gaps and adds meaning to those objects. If you otherwise trying to break it into like a photographer, and if you want a computer vision system, if you want, it's too difficult to solve. I mean, you can, and that's how we've been trying so far to solve it, like at the industry level, but it's just led to very complicated, if you want to stay in an analogy, cameras, and very complicated and very bulky and compute intensive AI systems. So we want to bridge actually the two phases And to do so, we actually built a sensing system that's comprehensive. It brings together all the sensing modalities together because there are different physics that we actually can actually read of the world, and they all give you like little different information. So you want to look at the world through different dimensions, and they're all by themselves individually incomplete. But it's a combination, an interplay simultaneously that actually eventually brings to this solution and the understanding of there's something out there. And that thing is that object, if you want that semantic content. So we have built a consistent system that comprehends a LiDAR, a camera, and a radar, and we build them all from scratch, starting from the fundamentals. Because these capabilities of bringing perception and intelligence to the sensors was not possible with, if you want, existing systems out there. We also recognize the problem of the space not being, this particular sensor or that other particular sensors. The problem is bigger than that. It's actually sensing and perception. That's what we need. And it's very difficult to solve when you do it in a compartmentalized way, when you actually look at a very small slice of the sensing system. So we decided that a holistic approach was much more efficient, much more powerful, intelligent. It will enable us in the entire space to go to the next stage. So we wanted to also, from the practical point of view, simplify the sensing problem. As of today, anyone entering and developing autonomous vehicles has to develop this independent path of developing all the sensing modalities, which require also getting dedicated skill sets and dedicated teams and research project, development projects. And if you want, those are like a bit of like a sidetrack to the main goal. So these companies and everyone is after autonomous vehicles. The reason why they're developing this subsystem is because they're a mean to an end. They were never the end themselves, right? Somehow they actually absorbed a lot of resources that become a rabbit hole in what is actually our main and ultimate goal. So we decided that the industry was right for actually consolidation and more, if you want, finally having a comprehensive sensing subsystem that on top of which like the entire industry could actually build autonomous applications. So that's the direction we're going to. I think that's what we need if we want to have truly functional, truly driverless and scalable level 4 and level 5 vehicles. I think we're on a good path. I think just the industry has gotten to the level of maturity we're ready to do this step now. If you want, we learn a lot from what we call autonomy 1.0. Now we're getting into this new stage where we're more mature, instead of actually just, putting together different sensors from off the shelf makers, often developed for different applications, and oftentimes just designed to build black boxes that you don't understand or control. It was time to get something much more, if you want, nuanced, sophisticated, and powerful. So that's the approach that we got. And so we've been in business for a little more than a couple of years. We're based in Redwood City in Silicon Valley, California. A large part of my team, including myself, are actually coming from Apple, but we have top engineers coming from Intel, Google, Amazon, and all the top sort of AI and sensor developers in the world. It's a very difficult problem, but I think we decided to go after the largest problem, instead of actually focusing on a single component. I think all those approaches so far have not paid off well.
So, but if we take this, we take the camera and the LiDAR, that's hardware, and that's all about basically grabbing the data associated with that from the outside world. You need to bring this up against some model of the world, some world knowledge that you have basically to bring it up against to even do any sort of recognition or any sort of identification. How are you folding that together in a single step? And of course, all this evolves. As I like to say, I don't drive down the road doing this. One frame at a time, and start all over at the beginning of the frame saying, where in the hell am I and what the hell's going on? I mean, I think at least the way this whole thing is designed is that I like to also say when I wake up in the morning, I'm there, where in the hell am I? And then it's sort of, and it evolves, and then finally okay, whatever. And that whole process, and of course one of the beauties of driving is that you always start at rest. I think always, that is a true always. I don't think you start in the middle of a whatever going, who knows what miles an hour down what Autobahn. Okay. I mean, you start at zero, which is an enormous advantage because you have the opportunity to acquire and build a whole perception, a whole fundamental world knowledge, world scale, of which then what you're doing is basically improving and iterating it. You're working off of a base. You're doing variational things rather than, oh, I got to do it from the start. You know, and to me, that's kind of a fundamental. Some of the things that I think are missing from, although I don't know the guts of any of the systems except for the ones that I've built. You know, you can't start from scratch each time and say, yo, I got new data, what the hell's going on? You know, I don't think, but you know, so tell me how you're sort of taking that even farther in terms of integrating these two phases.
Yeah, absolutely. I think that capacity you just described is what we call intelligence, right? It's actually
I don't know. I guess I hate. You know, there's certainly no artificial version of that. That's for sure. So go ahead.
The ability to extract essence from like infinite information to actually get to what is important, what actually has meaning, if you want. It's the difference between semantics and a picture, right? And then semantic information is very synthetic, very short. It's like it's the most reduced information you can actually synthesize a picture. Oh, you have a picture of me. You can just say Alberto Stochino. That can come down from megabytes to a couple of bytes, right? That's what we need to do, right? Because otherwise it's too much information. So now all this decision process, we sort of it was overlooked, but even this data that comes to your perception system has already gone through a lot of sort of like decisions and algorithms and, if you want, interpretation. So there is a lot of...
No, that is very true. Okay, go ahead. Yes, absolutely. And filters and who knows what you end up with, for which you say, oh, I know that exactly, but whatever. No, you know, it's not R, G, B, and D that you have at each pixel. I mean, go ahead.
There's a lot of decisions that happen under the hood that we're underestimating. And the problem is that those are actually probably the earliest decisions that even just our kind of naive and simplistic sensors to do, they are probably the most important because they're dealing with the first, the freshest, and the richest data, right? So even the data that, think of like what you get from your radar, these plots that sometimes they're turning to in a way that actually can be digested from human eyes. And so I don't know if you've ever seen some radar clusters or maybe plots. They're a very distant representation of what actually is coming out from the radar. The radar sees the world in a very weird way, like an alien, right? And so, but there is a logic right now, today, baked into the sensors that is making the decision. Like, that logic is extremely primitive. And it's actually wasting a lot of information, and it's already conditioning and limiting the capabilities of the downstream perception systems. So now, because we've always separated this process in two different problems, we have serialized it, right? And that has just made the LiDAR very complicated, unable to solve the problem, overly complicated, more than it needed to be, right? And so that's sort of like complicated and expensive, and it goes to LiDARs as well, actually even more if you want. And then down there, we have perception, and is dealing with this sort of like trickle down, super simplified version of the data, and is trying to extract meaning from that. Now, I think we believe that perception important, all this like very complex AI and intelligence we apply down there can and should also be applied down there. If you think of like prior decision processes, like Bayesian statistics, right? For instance, you are asking a radar or a LiDAR to make the decision about whether something is out there or not, because when they're actually giving you a pixel, they made a decision. They decided that the pixel was real, that there was something out there. And the way they're making the decision today is extremely simplistic, really naive. And like not only, and they're doing it just by themselves. So they're using their own partial information, say light information in the case of LiDAR, or RF information, microwave in the case of radar, to make the decision. And oftentimes, you can have different problems when you do that. Either for caution, you don't make the decision because maybe your data is not clear enough and it's ambiguous. So the maybe cautiously, the radar decided, I will not tell you anything. You know?
Yeah, I'm afraid of the false positives and false negatives, and therefore I throw it away and I don't rely on it, and I stick my head in the sand, which is, you know, a big problem I have with. Yes, go ahead. Yeah, no, absolutely. It's fundamental to what's going on. Yeah, I agree.
But when you look at it actually, and if you actually had access to the data, even before each of the two modalities made the decision about that pixel, right? You look at the data and you intersected and you made a decision with the prior information coming from the other device, well, all of a sudden your conclusions can be much more different. It can be much more powerful. You can extract signal in even with a lot of noise. You can actually avoid false alarms, right? In a much better way, because data can actually intersect and you complement and reinforce each other. So that's like one of the.
So you know, I guess I'm a pragmatic person. An example of just one little one where, you know, this really, you tripped over this when you figured it. I don't want to say tripped over it, but it came up and you said, oh my goodness, this is how this thing's going to work. Give us a minute. Do you have one of those sort of, you know, tell me about it.
Yeah, imagine, oftentimes you're looking down the road and, you know, like, it's very difficult. Like, it's very difficult to look, say, at 400 meters. You know, people want to have the longest range so you can have enough reaction time, right, to make decisions.
Well, I don't know if you want to go down the Autobahn. If you're just asking to drive through Princeton, or, you know, what, 99%, then you don't need it as much. But whether you'd like to have it long, but sometimes you don't really need it long. I mean, you know, there's nothing to do yet, so why bother? No, go ahead. I'm listening. I like all that. Go ahead.
Absolutely. You don't need long. Long is just sometimes a proxy for sensitivity, because if you can see far, it means you can also see weak objects even when they're closer to you, right? You can see smaller objects.
Yeah, but, you know, if I see too many, I like to also say that one of the things the brain does very well is it forgets. It throws out a lot of stuff.
Absolutely.
It gets rid of a lot of crap.
Exactly.
Okay? Otherwise, I mean, you think about how many nerve endings we have in our bodies. These things are like, I think, doing stuff all the time, yet most of the stuff, you know, we get rid of. And to say, hey, I got more of the things farther, I got something to me, that's not what to go after. I need the important things. Exactly. I need the few things. Yeah. I just don't want to go boom. I just don't want to go out of my lane. This isn't a hard problem. Okay. I mean, when you get right down to it, there aren't many. Look, and all sorts of objects, animals that have very few neurons, very small visual cortex, do collision avoidance very well.
Yes.
Okay, and so that, and why? You don't need the so go ahead. I love and I think that's where you're going. So go ahead. Let me hear some more.
And it's exactly what we also were saying before, the ability to kind of synthesize information to the essential and throw away 99.999% of it, right?
I'm never impressed. Oh, somebody where it's big data. Get out of here. Most of it is boring.
Correct.
Okay, throw the darn stuff away.
Correct.
It's useless. And let's get to this. Let's get to the real stuff that makes a difference. I don't know. Exactly. So I guess that's what you're doing, right?
Exactly. So we advocate to actually make that selection, the filtering, and tossing away most early on, because that's where you can actually take the precious data. And it's very difficult for you to do that if someone else has already done it, especially in a very simplistic way and when you don't control. But
of course.
Yeah, and so that's where the industry was stuck at, But if you look at making pragmatic examples, you can just driving, there's the traditional mattress on the road. I don't know you guys, but here in California, we have a problem with this. There's mattresses on the road all the time. And, it's actually very difficult to spot for several reasons, even if it's at near range. And sometimes you see something, a blip in the data, in this, call it raw data, and the system could actually just think it's a fluke. It's not clear. But now you look at the other modality, you look at radar, and you also see a tiny blip in the data. And you
Yep.
look also at the features in the data, and you look at a lot of commonalities.
And you look at the correlations of those guys, and it's the correlations that are
And you go,
important.
all of a sudden together, you put 2 and 2 together, and what it could have been a fluke, now it's much more unlikely to be a fluke, right? And now you could have solved the problem and say, oh, I don't need that. I'm just going to make a 4 times as more powerful LiDAR, 4 times as more powerful radar. Hey, sometimes that's not even possible, or if it is, it's going to cost you a fortune. And you're just acknowledging of being sort of, if you want, stupid, and not to want to solve it in a smarter way.
Yeah.
And
Elegance versus brute forceness. You know, I mean, go ahead. Yeah, right. Go ahead.
Another example. So, radars are fantastic, but limited. They're great. Their greatness is also their weakness. They can actually see beyond objects. That's amazing. That's why we can actually take phone calls even inside the house. You get the antenna can actually goes around and throughout the walls, right?
Yeah, it bounces off of stuff, and that really hurts you.
That's a weakness. It means that you can see a lot of stuff at the same time, and you struggle to understand what's what. You get all these delusional signals. Now, the information is there. It's just very difficult to disentangle. It's very puzzling and ambiguous. Now, oftentimes, this problem can be extremely streamlined and solved if you make some assumptions, even some prior information from the other sensors. For instance, the geometry of a scene. You're driving, say, and you have a bus next to you, and the radar is bouncing off the bus, but actually looking at something that is actually opposite to the bus, right? But your radar doesn't know. It thinks it's actually across there. Now, the decision that you get from a radar today, radar doesn't know anything about the geometry. It has some baked-in kind of one-size-fits-all decision algorithm process that's been decided by someone else, and you, perception computer in the car, has to deal with that. Instead, if I actually feed my radar information from the camera that is actually have this geometry around me, all of a sudden it becomes instantly clear. So you can solve what they call multi-path problem in radar much more effectively without making the radar any more complicated, right? Actually, I can make it simpler. I can make it cheaper because I can tolerate these things better. So that is a lot of like the advantages that you get. We took that to very far sort of results on LiDAR especially. We designed we made a completely new LiDAR from the point of view. And we have this unique access to this raw data. And from this point of view also, we don't claim that then we have all the solutions to how to better marry data from different sensors at the level. I think people are very clever. There is a lot of like expertise going on in the industry, in academia. What we want to do, we want to empower and enable people and to leverage that information. So we're creating a platform where all this information becomes available for them, and they can actually use to build their own detection engines. And detection engines that are actually working very closely with their downstream perception engines. So, and this is the way that, they can actually have them collaborate and work in each other. And they can, right now we actually have in this process camera, LiDARs, and radars, IMUs, and GPS. And we have our own decision process that we put in there, but we're creating a framework, if you want an interface, that people can actually leverage to access the data and making their own decision, their own priorities. Another example of like this streamlining information, right? You don't need all this LiDAR information out there. You don't need 360 everywhere with the same resolution all the time.
Amen.
Right?
I mean, why? I mean, it drives me nuts to look at some of these LiDAR images, and it shows me all the trees and buildings along the side of the road.
So, Alberto, I was going to say,
they're used. I'm not going to hit them. I'm between two white lines. Show me where the lines are. Show me where the road edges are. Show me where the overpass is that I can pass under. The rest of the stuff, hey, I don't want to do slam. Okay, I don't care where I am. I don't need slam. What do you give me all that stuff? Throw it away. It's useless. I don't know. Never mind.
Alberto, what I was going to ask you is, do you have customers or partners for your technology that you can talk about?
So we have already interactions with the key players in the industry here in the Valley. We've actually already, started interacting with many of them. We have our, if you want, internally we call it the 4th generation system. We have our own vehicle. We demonstrated it. We showed it to customers. We're continuing to expand it. And we're getting to the point that the system is at least in 1 unit ready for, scale. That's sort of what we did in the past. We went back to the fundamentals. Like we are a small team on that, and we went back to rebuild the really fundamental building blocks of these technologies. Because we also saw problems. I think if you wanted to solve the problem in a much better way, simpler, cheaper, more powerful, you have to go back and change the methods that we were using to actually sense. And we've done that for both LiDAR and radars. We thought the cameras are actually much more mature. We could actually leverage a lot of camera in the market, but LiDAR and radar especially were extremely limited in the way they were out there. And especially, no one has really considered that both of them are trying to solve the same problem, which is depth sensing. They're just doing through two different ways to look at the world, right? And so there was a tremendous opportunity to have them work together. And that's what we're doing, our concurrent sensing approach. So what we do, that's what we did in the past few years, and especially the first, I'll give you an example. So for instance, how we change the methodology we do sensing. We have realized that we have one of the most powerful technologies we have out there in the world, much more successful, probably. Like it's like a piece of future technology just landed on our lap for some reason. It's telecommunication. The ability to send information over long distances at the rate we do today. If you look at the success of like fiber communication or wireless communication, it's just amazing. Like people sometimes marvel at the beauty or the success of like a mobile phone and forget that probably one of the most remarkable aspects of a mobile phone is the telecommunication capabilities in that device, right? And that it goes back to information theory, the ability to actually send information through a channel, even in the presence of noise and disturbances and so forth, right? That's what now we can streamline data through a single fiber from Los Angeles to Tokyo at 20 terabits per second, right? With commercial devices for little money, right? That's that. So we actually reframe sensing as a telecommunication problem. And that, for instance, the way we actually interrogate the world, we actually send information out, either to our laser beams or our RF beams in the case of radar, and we collect when it comes back. So for us, sensing is nothing less than sending and receiving data. And that's a problem that we know to solve very well, right? We solved the problem for the past 70, 80 years or more, right? And when you do that, you have access to these very tremendous technologies and these methodologies and algorithms and form factors and architectures that we didn't have before. And so now, because of that, we can do all the things we were saying before, and we also control the entire vertical structure of the sensing process. And we can actually intercept and access the data at the lowest possible levels, and we can make that available to our customers. So people can now actually access the data as well as the algorithms. We want to enable them, not replacing them. I was part of it. I've been in this business for a long time, and we've always considered this. This is the product that I've always wanted in my career, right? The product that will enable me to do sensing, not that will just do sensing for me. And so that's what we did. And so we have I'll give you an idea also how many advantages. It's centralized. So like a data center. So we have a central unit in a vehicle. It's just one single box we keep in the middle of the vehicle. And I'll give you an example for how it works for LiDAR. It's all in there. It's a centralized one single compute, one single laser, one single transmitter receiver, all just one in the vehicle. And then we have optical fibers that actually just depart from this box and go to these small antennas that we place all around the vehicles. These are small and inexpensive. We can have as many as we want, right? And the thing is, like now, we're now replicating the same sensors all over the vehicle. It's just one component for the entire. So one single laser, one DSP, so tremendously saving complexity. And so now we have all this information that we send out in the forms of bytes. We send out and then collect as it comes back. And we can also correct, and fix, because we're sending information, not signal. And now we can do it in a very centralized way. And effectively, we have shifted the problem from the hardware to the software. And that scales tremendously well, right? If anything that the industry had taught us is that as soon as you move yourself to software, then tremendous new capabilities open up and scaling capabilities. So you can solve the entire vehicle just in a single pod. Same thing we do for radar, for instance. And then we have them actually working together, and we use these heuristics coming from different modalities to actually further combine, reinforce, and complement the data. And then we make it available. And we let people also, if you want, change the algorithms if they want in place. So that's sort of like the way that because we use all this new technology, we could do this like multiplexing, this also sharing the hardware, saving, using off-the-shelf components from very commoditized, already inexpensive telecommunication industry. So we changed the fundamentals, and all of a sudden, all these new opportunities opened up for us and enabled us to do all these things that we wanted to do for the final product. But our ultimate vision is to truly enable perception and artificial perception, and we use it to do it in a holistic way and solving sensing.
Well, that's very interesting. I agree with you. Going back to the beginning is a good thing to do today, and I think and to the fundamentals is very good. Your play on communication sounds very interesting. The pendulum going between hardware to software, back to hardware, and so on. That as to which one's better seems to go back and forth, over the various years. But but that's yeah. I think we're sort of on. There's the enormous improvement advancements on the software side, or on the bits and byte processing side is rather than analog versus digital. That darn thing. Every once in a while, the analog comes back, and then you go back to digital. We've gone through those cycles a few times, but it looks like anyway, it's really good. So thank you for giving us a flavor of what you're doing. It sounds very intriguing. I'm gonna be sure to follow it closely, because I think they have the opportunity, and you're looking at trying to address the right problem. Bringing these two things together does seem like an opportunity, and it should also be doing it. We do these things continuously. We don't do it once and then start over again and do it again. We take some time to ramp up, but then we get ourselves going. And we go. And the going is a variational process rather than a let's start from scratch again. And that's it's just fundamental to me, and I think that's fundamental to your approach. Fred?
We'll continue in just a moment, but this is a good time to remind you about our sponsor, the Smart ETF's Smart Transportation and Technology ETF, symbol MOTO. To get more info, head to motoetf.com. And on that website, we're pointing out that it's a good idea to read the white paper. It's titled The Smart Transportation Revolution. Under the Insights and News tab, there's a lot of great information there to help you make an informed decision. And you may already know that ETFs are a smart way to spread risk with your investments, and you can focus on a particular category. The site again is motoetf.com. Let's get to some of the headlines in the latest Smart Driving Car newsletter. The U.S. Department of Transportation has announced the first participants in a new automated vehicle initiative to improve safety, testing, and public engagement. It's taking a voluntary approach when it comes to the collection and sharing of data from autonomous vehicle operators. 9 companies so far have agreed to participate: Beep, Cruise, Fiat Chrysler, Local Motors, Navia, Nuro, Toyota, Uber, and Waymo. Alan?
I think it's great. I'm happy to see the focus on sharing safety information. I think safety is an industry objective. If this isn't safe, it's not going to happen. Nobody's going to sell anything. And so therefore it is imperative that it be safe. And if one entity is unsafe, then basically that just has a bad spillover to everybody else. So in fact, safety should be a cooperative effort and not a competitive effort. Sure, there's some aspect of intellectual property in everybody's approaches, but my goodness, with respect to safety, that should be shared. Most unfortunately, much of the safety, you have to trip over it before you see it. we all try to make sure that we can anticipate it, but guess what? We're just human, and our anticipation capabilities are somewhat limited, so we have to trip over it. And when we trip over it, we should share it and let everybody know. And I think that that's what this initiative is fundamentally about, is for everybody to share their corner cases, their really tough ones. Maybe not how necessarily they're choosing to address it, although why not? If you can help somebody else become safer, you become better because they don't screw it up and ruin it for you. It's just so fundamental. And so I think it's good. Some people would like to see us be, I don't know, Soviet Union or something, and have it all legislated and regulated and a bunch of rules that everybody has to follow. Who's going to write those rules? Nobody even knows what rules to write. So, having everybody work together and realize that that this is really important, safety. If it's not safe, nobody's going to use it. There's no market. You're not going to sell it. It's
well,
not
that's what you've
work.
talked about before, is the marketplace determining where this goes, and everybody loses if there's another huge crash.
Absolutely.
That ruins
Look
everything.
at what happened with Alain Herzberg. Okay, Uber lost 60 billion in market cap. And
but
market
it set
value,
everybody back at the same time.
It set everybody back. Has Toyota even gone back out and done testing since then? I don't know. Maybe I'm not. Maybe I'm asleep someplace and I'm not. Whatever. Probably. But it set everybody back. Now I think it's good that it set everybody back and said, "Oh my goodness, do we really have a loop in our code that says if there's an object in the lane ahead, but it's stationary, disregard it because I don't know what it is, and therefore it's probably just something I can pass under, so let's go." I think everybody, I hope, went in and looked, do we have that part in our code? If it is, take it out. Let's figure out whether or not we can pass under it or not. Okay? Which they still can't do very well, but whatever, and that's a whole other story.
Alberto, any thoughts about what the DOT is doing?
Absolutely, I agree with Alain. Yeah, safety is critical, and I think people realize that. I think people are trying to do it proactively before actually the government crazily mandates in an unpredictable way, and people are always waiting for the wild card. It's sort of like probably one of the biggest uncertainty over the industry, like the idea that one day the government will wake up and come up with some unreasonable restrictions on that.
I think the other reason, maybe I'm just too cynical. The other reason why one wants the government regulations is if something happens, they have something to point to. It's their fault, not mine. They told us to do it this way. I mean, come on. All right. I think we should be we should be beyond that. I think that the fact that people are going to get together and at least share safety information is great. But this has to go much more beyond testing. I mean, the focus, testing is easy. You have a human in the vehicle who's, hopefully you're paying them and they're paying attention, and they'll make sure nothing at least extremely bad or extremely bad happens. The issue is that if this is really going to provide mobility and valuable mobility, and that the automation is actually used to its fullest, and that means that we've taken the driver out of the loop. No longer there. This is a mobility machine. And now it has to be, it has to be perceived to be safe by the people that are using it, by me when it's driving down my street, by the community, by all those folks. And I'm not sure that this program is going that far. It should. It has to include it mentions nothing about mobility, mentions nothing about communities, and it mentions nothing about neighborhoods. I mean, are these things only going to run on the New Jersey Turnpike? If they do, New Jersey Turnpike really doesn't go from anywhere to anywhere. Okay, you got to get to the Jersey Turnpike. You got to get from the Jersey Turnpike. I don't know, whatever. But it's a start, and I applaud it, and I think it's very good. It's a way to get going. Unfortunately, it includes nobody in the Northeast. So please, why was New Jersey not in there? It doesn't include a bunch of other players like Ford and so on, so that are kind of missing, and probably should be in there. And so I don't know, but it's a start. It's important that we get started.
Bloomberg is reporting that Renault is rattled that the threat from Chinese electric imports is coming, a flood of those vehicles coming ashore in Norway. This is something our friend Michael Senna has been talking about for some time.
Yeah, I think there's some implications on that. If now a skateboard is so easy to make, we're going to have them all over our sidewalks. Oh, that was scooters. Okay. They're how much more difficult? Throw a seat on it, whatever. Look, once you have such a simple propulsion system as an electric motor on a skateboard, you no longer have a transmission. You no longer have pistons and valves and I don't know. Be interesting.
And we should point out.
I think they should. I think people. I just think it'll be interesting. I don't know.
Well, Michael has another great edition of the Dispatcher.
Yeah.
People can read more about this there, and lots of other stuff too.
Yeah, he has. He follows up on that. He also follows up on the Zoominar that we had with respect to connectivity, and the whole connectivity question still needs to be addressed by the industry, and how, the various pieces and elements as it is. It's a three-sided coin, I mean, it's tough enough with a two-sided coin to get that side. What do you do with a three-sided coin? I mean, what the hell does that look like anyway? Go ahead.
Well, we always have something to say about Tesla. They're now saying the long range plus Model S now has an EPA rate range of 402 miles, the first vehicle to reach that mark. It had been down at, I think, 391. Tesla also recently reduced the price by $5,000 as well for the Model S.
How big must that battery be? And I hope I never have to replace it. But one of the batteries have always been part of the tough part of that business. And I guess I've always been of the opinion that batteries haven't enjoyed Moore's law, and we're barely better than we were in 1837 or something like that with batteries. But it seems like maybe they are improving a little bit.
Well, they're talking this million-mile battery, aren't they?
And there's talk, and then you got to walk the walk, But even to talk about a million, I mean, that's we get anywhere close to that. Hey, let's just reduce it by an order of magnitude. That's doing pretty damn well, really, when you get right down to it. And so, yeah, it may be. And if we solve the battery problem, if we solve the battery issue, and batteries become cheap and they become whatever and so on, and this thing's trivial. I mean, then there is a flood of these guys coming in or whatever. And I guess maybe Elon's going to be making them in his whatever factories that he's building all over I don't know.
Oh, you're talking about Chinese EVs. I think Elon's selling a lot of electric vehicles.
Yeah,
in China.
Apparently, I guess at least we'll wait and see what his next meeting with the investors are. But wow.
Carnegie Mellon making a little news. They've got a new method to make more data available for training self-driving cars called Scene Flow. They're saying it can utilize much larger data sets. Seems to run a little counter to what we were talking about a couple minutes ago. But
well, I don't know. I guess, I tell you the truth, I don't believe it. Okay, because I put some things in there and in the newsletter that says, look, they claim that they don't need labeled data, yet they're going to measure a distance to the real point. How did you determine what the real point was? Who did that? What did it do that? How did you do that? The real point seems like that's the definition of label, but I don't. It always troubles me to, unsupervised learning. If it was that easy, I mean, we would have had a great second half of last semester, okay? Because guess what? We didn't supervise any learning, okay? All this remote stuff was, how much learning went on? Oh, never mind.
Let's hope it's better in the fall. We'll keep our fingers crossed. We'll know
we
soon,
hope
right?
It's better in the fall.
Germany's Federal Ministry for Economic Affairs and Energy has awarded an innovation prize to Easy Mile, which has a fleet of 5 automated electric minibuses. They're operating in Mannheim. One of the ideas, according to the local transport officials, is to gain insights into the public acceptance of autonomous vehicles. That's a subject near and dear to your heart. Easy Mile has offices in France and Singapore.
Yeah, I mean, in the end, it has to be consumed. Now, if it's going to move people are going to have to accept it, trust it, believe in it, actually reach in their pocket and somehow pay for it one way or another. Okay, because there will be some expense, and so yes, that's important. There are attendants on board and so on and so forth. There are attendants on board everywhere except for maybe Phoenix. I don't know what Waymo is doing, to what extent, whatever. But to really take advantage of any of this automation and all this work on and try to make happen, the advantage, I mean, there are some comfort and convenience advantages. There probably aren't any safety advantages, except for the fact that if they're designed properly, they won't misbehave, and so you get the safety benefit by eliminating the human misbehavior that goes on, which is really powerful. But otherwise, the real value is in the affordability, and some of you guys can afford a chauffeur. Some of us poor souls that have, not even 2 nickels to rub together. I know, I can see you crying, right? Not so much. But I think, to me, that's the real advantage of doing this is to provide really good mobility to both people and goods, much more affordably and environmentally beneficially, if that's a correct word, and to do it. And then we're going to have to get back to sharing somehow and get away from this social hatred that we've promulgated on everybody.
Interesting thought, Alan. Before we wrap up, we should let you know that there's another live Zoom Tank session on tap for this coming Tuesday at 2 p.m. Eastern. The topic planned is insurance for or against smart driving cars. Alan, we've still got this on the schedule, and the people can keep track of it at zoom-tank.com and go there to register to participate.
Right. We're gonna talk about insurance, whether it's only going to be me who who goes out there and says anything, or it's going to be a few others that we're trying to get out there to say something. I've for a long time felt that this is an opportunity for insurance to lead rather than a decimation of the insurance industry, because there will be no crashes in the future and therefore no revenue opportunity for that sector. But
hopefully fewer crashes, and we've talked about in our last smart driving cars the debate about how much they'd be reduced. But
absolutely, I mean, when you look at if you're a company. I think, I don't know, you're a CEO. I used to be a CEO. Alberto, what are you most interested in? Bottom line or top line? I hope I was only interested in bottom line. I didn't care what the top line was. man, the profits are, now if you're flipping and so on, who knows? I mean, that's a whole other game. But I don't think most insurance companies are out there to flip. And so what if the top line gets hit? If the bottom line goes up, I don't know why, maybe, what am I? I mean, I'm whatever. I'm just here in this bubble of Princeton, out in the backwaters of New Jersey, whatever. COVID.
One room
Alberto,
school,
we try to have some
schoolhouse.
fun here. One room schoolhouse. I mean, I'm wearing my Crocs.
I have to say that I missed all the visual usually. I listened to the podcast and I didn't know what I was doing. Yeah.
Anyway, whatever. We just, hey, look, we try to have some fun with it. This is very serious business. This is very, very important. This is a fundamental part of the world economy and fundamental implications and fundamental opportunities. It's very serious, but some of it, every once in a while you've got to, we got to have some fun doing it too,
Yeah, no, I believe this is tremendous. This is probably the biggest revolution we have the ability to control. I mean, mobility will be huge. And that's in part why you see all this happening. I mean, the potential rewards and returns are just tremendous. It's beyond the internet size. This will be like internet interweaved with the real world.
It really is that. I mean, if there is anything that's artificially intelligent, having it do this piece of work for us, which if you look at it, who are we unemploying in doing this? We're all unemploying ourselves that have been forced into free labor of driving this damn thing for us to be able to get from A to B, for which when we're going from A to B, we have to sit there and pay attention and behave and follow strict rules and so on. Otherwise we die.
Yeah.
Okay, I mean, you think about the how much it puts on each of us. And so, sort of the liberation that it comes that we can then just like relax, I don't know, text, play video games. I don't care. Oh, hey, yeah, I'll write code and become more productive too. Sure, of course. Yes. Thank you, boss. But I mean, look, who doesn't want to be chauffeured? I mean, whatever. It's an enormous opportunity to improve quality of life, and if you can make it cheap and easy and whatever, and it doesn't go out there and pollute the damn world and kill the world. Whoa. There's not many things out there that can do that kind of thing. That's what's behind all this. That's what I think of. That's what keeps me going every day on this stuff.
And congratulations, Alberto, on helping to make all of this happen.
Yeah.
And we really appreciate you taking the time to be with us. And we want to point out your website is perceptivesensing.ai. People can go there for more information. And again, we really appreciate you taking the time with us.
Thank you very much, Fred.
Hey, thank you. Appreciate it.
And for anyone listening, if they want to reach out, please send me an email through the website. Happy to connect. We have a slew of exciting updates coming this summer, a very dense roadmap for the rest of the year. We'd love to keep you informed, and I'm sure you'll be intrigued.
Our thank you to our sponsor, the Smart ETF's Smart Transportation and Technology ETF. The ticker symbol for the ETF is MOTO. And more information is available at motoetf.com. You can find us at smartdrivingcar.com, also on Anchor FM, Spotify, TuneIn, Apple, Google, Spreaker, SoundCloud, wherever you get your podcast. And you can ask your smart speaker to play us too. You can find my tech reports at techstination.com. I'm Fred Fishkin along with Alain Kornhauser. Thank you for listening or watching, and stay safe.